Hello guys, this is Panos and welcome to my channel. Today I'm gonna show you how you can design your own Wi-Fi controller to control your water heater remotely from anywhere in the world. Let me show you the parts first of all. This is the device that I designed and I will show you later the PCB layout. This is a power supply, the power source, which converts 230 volts to AC to 12 volts DC. And this is the power relay. You can see here, A1 and A2 is the coil, and these are two normally open contacts. Okay, this is our circuit breaker, which is rated at, if you see here, 20 amperes. And this is the lamp, the indication of our circuit that it is on. Okay, let's see the circuit also. How are we going to connect this controller? This is the circuit breaker. So this is it. This is our power supply, which converts 230 volts to 12 volts DC, the controller and the power relay. It is very important to use a power relay which has two normally open contacts. This is very important because some loads like the water heater, which are very big, need to be isolated completely from the other circuit. So I suggest you to use two contacts here, not only one contact for your load. Okay, I think guys, now we are ready to test the circuit. Just to let you know, I have added the push button here. So in case we have an internet connection failure and we are at home, we are able to power on our water heater. Okay, so let's test the circuit first of all manually. So, and voila, now it's on. Okay, let's go to see inside. Okay guys, I think now you can see that this is on, our water heater. Very good. Okay, now let's go back and test the Wi-Fi capability. This is why I built this device, to have to be able to control it from anywhere in the world. Okay. Okay guys, now I'm going to shut down the circuit, the supply. Okay guys, now we will see you can see here, this is the Blink application. There are some buttons, start, you see, start, stop, set time, that we set the time. This is an indication, the status, and how many minutes this is running. Okay, now I'm going to, you can change this here, of course. Okay, I'm going to set it to just to 1 minute to see. Okay, now let's power on. Let's press start. And also I receive a notification that my water heater is on. Okay, let's wait 1 minute to see that this will shut down automatically. Just be very careful when you're experimenting with high power. It's very dangerous, and you should be a professional or have a certificate to be able to do modifications to power supply, to high power circuits. Okay, you see it's on, and let's wait until it shut down. Okay, now it's off, and also we receive the notification that the boiler is off. Okay, that's it, guys. I'm going just to show you the PCB. This is the PCB, guys. Right now I'm going to explain you everything you need to know, and in case you need, I'm going to share with you the Arduino code. This is the holder, the terminals, one input, one output, push button. This is the voltage regulator. This is the MOSFET. Okay, just for you to see it, I will explain everything you need, mostly for the hardware side. Okay, thank you. Now, in some minutes, we will see everything you need. Thank you. Okay, guys, now let's see what there is inside here. Okay, this is the PCB that I designed and ordered. Here, let's first of all see all the parts. We have 3 terminals. Input terminal, which is connected here. This is the input terminal. The output terminal, which is this one, and connects to our power relay here, A1 and A2. And of course there is one more terminal for our push button in case we have an internet connection failure, as we saw earlier. Okay, this is a general fuse. Actually, it's a glass fuse with holder, which is rated at 2 amperes. This is the voltage regulator, and this is the MOSFET. As a voltage regulator, I use the L7805, and as a MOSFET, IRLZ44N. This is a diode, and I will tell you later why we need this diode. And this is our controller with Wi-Fi capability. Actually, it's a board, Wemos D1 Mini, which is very convenient because of its size. It's perfect for our application because this PCB needs to be quite small. As you see here, it is 60 millimeters width and height 45.5 millimeters. Okay, I think it's better to see the schematic. Of course, it's not a very well designed schematic, but the important thing is here this connection should be you should be very careful with this PCB, with a PCB when you design a PCB. Actually, the schematic is not so important for our application, just it's better, it's easier to see here what is going on. Okay, this is the input terminal and the fuse. As I told you, voltage regulator is L7805. Let's see here the data sheet. Okay, here output current up to 1.5 amperes, which is okay for application. Inductor of the relays, of course, less than 1.5 amperes, and the maximum input is 35 volts. So here we can use any power supply up to 35 volts. Of course, in my opinion, best best values for your power supply is 12 volt DC or 24 volt DC, because if you change this here, of course in the output you should find a relay which is rated at a different value. Of course, most common values are 12 volts DC and 24 volts DC. So, in my opinion, here you should use a 12 volts DC or a 24 volts DC power supply. Okay, let's go now here to see again. So, this is the voltage regulator, and the output gives us 5 volts, which goes here. Of course, we use some capacitors here. You can see in the manual there are some circuits here. You can use these capacitors. Okay, we power on our device, and we use one input and one output. We use the input for the push button in order to be able to control our output, our power relay, in case we have an internet connection failure. And this is the output, D7 of our circuit, of our board. We connect a current limiting resistor here in order to limit the current in the gate of the MOSFET. This is a resistor which also, I think, it's very important, because when you power on this, if this is floating here, it is possibly that in the output you will have a fluctuation here. So in order to be sure that this will be off, this will be logical 0 when you power on this device, you have to use this resistor. Just to let you know, Wemos D1 Mini operates at 3.3 volts in comparison with Arduino Uno and Nano, which operate at 5 volts. This is very important, because our logical one is 3.3 volts here, and it is necessary to use a MOSFET that is able to be on at this logic level. So I use the IRLZ44N. Let's see the datasheet. This is the datasheet of our MOSFET. You see here, this is very important, logic level gate drive. Also, you will see an L here. In every MOSFET that it is logic level, there is an L here, which means logic level. You can see here VGS 16 volt, the absolute maximum. The threshold, VGS threshold 1 to 2 volts, minimum and maximum. And let's see the most important thing. As you can see here, for a voltage of a little bit more than 2 volts, we are able to, it is possible to have current in the drain to source path. This is very important, because if you see another kind of MOSFET, for example IRF 540N, if you see here, with this MOSFET it will not be possible to control our output, because it needs more than 4.5 volts to operate. So you can use this with an Arduino Uno or Arduino Nano, but you cannot use this MOSFET with Wemos D1 Mini. Okay, this is finally, this is the diode, which is very important in case you have an inductive load here. It is very important because in a long-term period you are going to have problems with your MOSFET if you don't use this diode. Actually, this diode let's say, filters sharp current changes in inductive loads, like our relay, which is inductive. I think that's it for now, guys. I can share with you the Arduino code, and in case you have a problem, you can contact me. I'm not going to explain here every command of our code here. You can use, you should write here your Blink authentication, SSID and password. These are the necessary parts. Okay, that's for it now. I will share this with you, and I hope everything will be fine. Thank you, guys. Bye.